Welcome back. I think this is the last video in this chapter. It's very unfortunate. So this chapter from now, from this video, it will be more algebraically complicated and very annoying. You are going to see many complicated notation. I wish I could use a blackboard, but so like focus on the video and follow more carefully. And I recommend you to prepare a pen and pencil, pen and paper, to repeat what I do here. So, in our previous example, we considered a kind of unrealistic portfolio. We only considered investing one unit of A and investing another unit of B. It does not work like that. We usually in theory, in finance, the major tuning parameter is the weight. How much of your money is going to a certain asset. Like for example, a portfolio. When we say a portfolio, it's usually sounds like 30% of a stock and 70% of some other stocks or bond, whatever. So it usually goes with percentage, probability. So we are going to mimic the more realistic financial portfolio of this at the price of more complicated algebra and more complicated notation. So now we are going to denote the portfolio this way. So suppose that you have $100 and you invest $30 on A and $70 on B. Then your return X is the portfolio return is 0.3A plus 0.7B. Right? So this is an obvious result. And we will be using these results. Already it becomes complicated. First, variance. So when you multiply something, variance is multiplied by the constant squared. The squared constant is multiplied to the variance. That's what I need from the first equation. We learned it in chapter 4. And second result implies that when you multiply C to two variables, their covariance is multiplied by A and C, not by the additive constant. So when you multiply 0.3 on A, 0.7 to B, then the covariance after the multiplication will be multiplied by 0.3 and 0.7. So 0.3 plays a role of A, 0.7 will be C. You are going to see, I'm going to use this result in the next slide. And finally, this is the main formula we have used in this lecture. So variance of A plus B, X plus Y is sum of the variances plus 2 times covariance. Okay, right? Then see this. So I am going to calculate the variance of X. That's what we want to know, the risk of the portfolio. So the variance of X, and X is the sum of one and another. 0.3A is one random variable, and 0.7B is another random variable. Then apply rule number 3, formula number 3. 0.3A plus 0.7B variance equals variance of 0.3A, 0.7B plus 2 times covariance 0.3A, 0.7B. Right? X must be replaced by the first part in front of the plus sign, and Y is replaced by 0.7B. Right? Simple plug-in. Then you get this. And now we have to find variance of this guy, covariance of these. And as I introduced in the previous slide, variance of 0.3 times A equals 0.3 squared times variance of A. So multiplication of 0.3 affects variance this much, amplified by the square. And similarly, variance of 0.7b is 0.7 squared times variance of b. Okay, so multiplying a number has this much effect. And covariance between 0.3a, 0.7b equals 0.3 times 0.7 times covariance, original covariance. That's the second result I wrote in the previous slide. Anyhow, then combine everything. We get this value. This guy is here, and the second term is here. The last term is here. By the way, remember there is a 2. You have to multiply 2 here. So, and we know a variance of A, we know variance of B, we know covariance between A and B. So you can calculate the variance of X. Let's do that. Oh, I didn't do that. We are going to do that later, I guess. So this is, you can do that. So the final algebra is not a big deal. You can calculate what you get. And we are going to generalize that. Instead of 30% and 70%, you may use W and 1 minus W. And so that's the weight. W is the weight on A, financial asset A, and the other remaining 1 minus W is invested on B. And following the same steps, just simply replace 0.3 with W, 0.7 with minus 1 minus W. Then you get this. This is the one of the most important result equation in optimal portfolio theory. And of course, in finance, there should be more than 2 financial assets. But in Finance 101, you are going to consider this one, and in there, the goal is to minimize this variance. So it's a quadratic function, so you should be able to minimize. So the quadratic function looks like this. So you have to find the minimum point. The minimum point that minimizes the variance. That is how you find optimal portfolio. But it's not a complete theory. I did not teach you everything. So if you're interested, you have to take financial economics class. I believe should be taught there. And here we are studying covariance. And then I am going to consider real data. From Exxon, Walmart, Microsoft, Apple. So you know what? These 4 companies all had been number 1 in capitalization, market capitalization at some point. I believe Exxon was number 1 in the 80s or early 90s, and Walmart was also was number 1 in 90s, and then Microsoft, and then Apple. These days, Microsoft and Apple are top 2. So I took kind of representative, most famous companies as an example. So then, by the way, this table is covariance matrix, covariance table. So the diagonal terms are variances. Exxon has a variance of 8.03, and Walmart 13, Microsoft 21, Apple 38. So in terms of the variance, Apple is the most risky asset here among the 4, and Exxon is the most safe asset among these 4. However, so in terms of the risk, Apple is the worst and Exxon is the best. But I did not show you the expected return, so it's not everything. And also, being stable may mean it did not increase that much. So risk includes increasing. If a stock increases steep, then we and then its variance will be large. So the reason why Apple is risky is because it increased too sharply. So it changed it too much. So in terms of the variance, it looks like it changed it a lot. Right, it changed it a lot, but in a positive direction, which is nice. And that will be reflected in the expected return. But we are not considering the expected return, so let's only focus on the variance, the risk. And the off-diagonal terms are covariances. And as you see, any pair of the stocks has a positive covariance. So all of them are positively correlated because obviously when the market goes up, all of them will go up together. And if market in recession, all of them goes down. All of them go down. So it's typical, it's common, it's natural. And let's consider a portfolio composed of 50% in Axon and 50% in Apple as an example. First example, so 50 in Axon and 50 in Apple. Apply the previous formula. Weight on Axon squared times variance of Axon, which is 8.03. And this is squared weight on Apple times variance on Apple, which is 38.35. And 2 times 0.5 times 0.5 times covariance between Axon and Apple. Again, if I were in the classroom, I would derive the equation on the board, but I cannot do it now. So please do it by yourself on a paper. Anyhow, it's a simple math. I believe you can just follow this formula and plug in the numbers. W is 0.5, variance of A is variance of ExxonMobil, and variance of B is variance of Apple. So plug in those numbers, covariance. Then what's surprising here is, it's not surprising, but so as a result, you get 13.11 is the variance of the resulting variance. So it's much smaller than 13.11. It's much smaller than Apple, but a little higher than Axon. So that is how we apply the formula weighted portfolios variance. And then let's try this. If you invest 80% on Axon and 20% on Apple, what would you get? What would be the result? You are doing the same thing like this, but change the numbers 0.7, 0.8, 0.2. So 3, 2, 1. The variance is calculated this way: 0.8 Axon, 0.2 Apple. So 0.8 squared variance of Axon, 0.2 squared variance of Apple, and then 2 times 0.8 times 0.2 times covariance. If you plug in the numbers, I do not show them, then you get 7.6428. What's surprising here is, remember this number, variance of this portfolio is 7.6, which is even smaller than Axon. It's a surprising result. So by combining two assets, you can make the portfolio even more safer than each of the assets. And what is even more surprising here is you are mixing Axon with the most risky asset, Apple. Still, the result is better than Axon. So you have safe asset. Maybe you may think investing everything on the safest asset is the safest way to invest. No, that's not. That's not the case. And this example shows mixing a little bit of other assets, even if it's risky, still may help reduce the risk. Surprising. And what is even more surprising here is their correlation is positive. the diversification is not coming from negative correlation. Even if their covariance is positive, still you can do even better than the safest asset. Of course, but however, it is an example, and I'm showing you an extreme example and simple extreme example, but this is not a complete investment theory because mainly because the expected return is not considered here, and you have to consider uh, more more assets in practice. But just as an example, still it's very surprising result. So this is it. And we learned how we calculate the variance of sum of two variables. And in the calculation, the covariance in particular plays a very important role. And as an example, as a main example for that, we learned briefly about the optimal portfolio theory and risk diversification theory. As I said, it's not complete theory, but just an example. And by the way, again, I'm going to warn you again. So far, we only considered linear relationship. But on an example like this, if this is the case, if the relationship is not linear like this, then our method does not work. So we have assumed that the trend line is always a straight line. Then from that assumption, we studied the slope of the slope of the line and the strength of the relationship. But if you expect something like this, it is a very strong relationship, but just it's not linear, then our method does not work. Our method is not applicable in this case. Okay, thank you for watching this, and have a nice weekend, and see you in the last chapter. Last chapter is the regression model, so it'll be more interesting. See you later.